So welcome everybody to this latest video on 160 Math, and in this video we'll be going over trigonometry with a focus on using the cosine and sine rule, which is basically trigonometry for non-right angle triangles. Now as always there'll be a copy of some notes in the description below along with a worksheet for you to practice everything that you've learned from watching this video. So we use the cosine and sine rule in a similar way as we use SOHCAHTOA trig for right angle triangles to find the missing sides and angles in non-right angle triangles. So here if we take this any non-right angle triangle, so there this triangle on the screen looks like an isosceles triangle. It doesn't really matter whether it's scalene or an equilateral triangle, as long as it's not right angle then these rules will apply. Now in terms of labeling the triangle, which is obviously one of the first steps when you're using trigonometry, is if you just pick one of the angles, it doesn't really need to be, let's say, the left hand side angle, and we call that with capital A, then the side opposite that, which is this side here, we would label as lowercase a. And likewise, if we label one of the angles B, then the opposite side is going to be lowercase b, and if we label the third angle as C, then the side opposite that would be a lowercase c. Now when it comes to using the cosine rule, which is these, now although these formulas look a little bit complicated the first time you look at them, sometimes in most exam papers they will be given to you. However, when you're practicing and doing revision, then it's important that you do. Now I personally believe that if you practice these questions, learning these formulas will become very, very instinctive. Now looking at the cosine rule first, let me just put a little bubble around that. Now there are two variations of the cosine rule. One is predominantly used for when you're finding missing sides, and the other formula is used when you're finding missing angles. However, if you are really good with rearranging the formulae, you should be able to spot that both of those two formulas are exactly the same. It's just got a different subject. So here with this first one, we use finding a missing side. And with this formula here, we use when finding a missing angle. And we'll go through, when we go through some examples, we'll show how to use these particular formulas and rules. Now, one thing I would suggest that when you are using the cosine rule to find a missing side of a non-right angle triangle is to put brackets around the 2bc cos A. Now, it's not extremely important to do that. Obviously because it's not actually in the formula to have those brackets, but if you are typing it into a calculator and you're dealing with potentially some complex numbers, then I would suggest sticking that part in brackets just to make sure that your calculator doesn't do anything crazy to give you the wrong answer. Now moving on to the sine rule, so here we've got three fractions. Now what you generally find is that one of those letters, just like with the sine rule, one of the letters is going to be the thing that you're trying to find. So whether it be lowercase a or capital A, lowercase b or capital B, or lowercase c and capital C. Now in this, you're only going to ever only need two of these fractions. So for example, now we'll go through when to use the sine rule. So for this, depending on your labeling, you don't need to label everything that's on the triangle. So when you see a non-right angle triangle, there is no need for you to label everything. So you don't need to label that A, little a, B, and C. That looks like a C there. And that's going to be C, and that's going to be lowercase c. You only label sides that you've got information on or is the thing that you've been asked to find. Never label any blank sides. So just bear that in mind because it will confuse you and could make using these formulas a lot more complicated. So for this, I would suggest that you only work with A's and B's and then you just label your triangle accordingly. Now in some revision guides and some websites, you might find that the sine rule can be written in a different way. So another variation of the sine rule is having sine A above in the fraction above lowercase a and sine B over lowercase b, and that is exactly the same. Now if you know you're cross multiplying when you cross multiply, they'll both equal the exact same thing. So these two things here are the same. Well, they will give, in terms of the fact that they both will give you the same answer, where one of them is what you're asked to find. Now, a common question I always get asked as a teacher is, when do you know when to use each rule? Now, in a maths question or a maths exam, there'll be no indication about which rule you've got to do. Now, in some cases in textbooks, they will say, here's 15 questions using the cosine rule, here's 10 questions using the sine rule, then you know which rule to use. But in exam conditions or on your homework, it might not be quite self-explanatory as to which rule you've got to use. Now, for this, what you've got to do is apply a bit of common sense. So it all really depends on what information you have been given in the question, and you'll only ever be given one or the other of this based on this. Otherwise, it doesn't really matter which rule you use. You can always then find out what x is or what it is you're actually trying to find. So if you are given 3 sides and 1 angle, so that would look something like, so here let's go for x being an angle, and I know this is 3, this is 4, and this is let's say 3.8. Then here I've got 3 sides and an angle. If I had, let's say, let's just change that up. So that therefore would mean I use the cosine rule. If that was 36, this is x, that's 12, and this is 13, then again I can use the cosine rule because I know 3 sides and an angle where one of them is x. Now, to use the sine rule, I need to know 2 sides and 2 angles. So here an example of that would be, if I just quickly draw a triangle, so here let's say that's 36, this is x, that's 12, and let's say this is 8. So here you can see I've got 2 sides and 2 angles where one of them is x. And another alternative would be something that looks, let's say x is there, here's an angle, let's call that 40, let's call this 50, and let's call this 6. So here you can see that I've got 2 sides, 6 and x, and I've got 2 angles, 40 and 50. So therefore then, to work out what x is, I would use the sine rule. Now, just like with SOHCAHTOA trig, there are some certain steps that you can do this. Now, I would suggest that you follow these 4 steps. Now, although there are 4 steps, doesn't necessarily mean that each question is going to be worth 4 marks. However, some of these you'll be able to do in your head, some of them will be done in a couple of seconds. But I would say if you follow these 4 steps, you're going to limit the number of mistakes that you're going to make, but also maximize your marks when it comes to exam style questions. So the first thing you want to do is label the known sides and angles of the triangle. Now again, with angles, that are going to be capital letters, sides or lowercase letters. Now, a good tip is always to start by labeling x, or what it is you're actually trying to find, as x, or as either capital A or lowercase a if it's an angle or a side respectively. And again, the key thing here, just as I've previously mentioned, is do not label blank sides or angles. It's just going to confuse you. So if you've got an x on your triangle, label that as A, lowercase or uppercase, and then label the other sides respectively, remembering that opposite sides will be the same letter. The next thing you then need to do is to pick the correct rule of use. So for example, if you've got 3 angles and a 3 sides and an angle, you're going to be using the cosine rule. And if you've got 2 sides and 2 angles, you're going to be using the sine rule. The next thing then is to make note of the formula and substitute the values in correctly. So again, this is where now I would suggest that if you've not done this before, then I would suggest that you always write down the formula, because it's a good way of remembering that formula and revising, keeping that formula retained in your brain. And the 4th step is then to calculate and rearrange the formulas to make whatever it is you're trying to find the subject. Now, a good tip is that don't forget to square root when finding the sine using the cosine rule, and don't forget to inverse cos or inverse sine when you are finding an angle. Now, when using the sine rule, remember that if you're finding an obtuse angle, to subtract the calculated answer from 180, and this is what we call an ambiguous case, will be, and again, this is more high level non-right angle trig, and again we'll go through an example where we need to use that final part. So let's get started on some examples. So in this particular question, it says find x to 1 decimal place. Now, In most cases, non-right angle trig will always be a calculator question. The only time it will be a non-calculator question is when your angle involves either 30, 45 or 60, where you're using the exact values of trig. But again, it's very rarely does that come up. So I would say 95% chance it's always going to be on a calculator paper. So looking at step 1, what we want to do is label this triangle first. So here I'm going to start off with x. So x is a side. So I'm going to start by calling that lowercase a, which therefore means that the angle of 87 is going to be my capital A. Now I've got two sides, so it doesn't really matter which one I call B and C, as long as I call them B and C. So I'm going to call 6B and 10C. So here, let me just quickly write down what I've got. So little a is x, B is 6, lowercase c is 10, and capital A is 87 degrees. Now looking at this, I've got three sides and one angle. So therefore what I'm going to use is I'm going to use the cosine rule. Now again, you don't need to be writing this down. This is what you need to be thinking. Now with the cosine rule, there's two variations. So there's one variation when x is a side, and there's one variation when x is an angle. Now in this particular case, x is a side, so I'm going to be using a squared equals b squared plus c squared minus 2bc cos a. So again, I'm just going to put brackets around the 2bc cos a. Now for this, what I then need to do is substitute these values into the formula. So what I've then got is I've got x squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times cos 87. So then if I type that all into my calculator, which I'm going to do now when it loads up, there we go. So from this, I've got 6 squared plus 10 squared minus bracket 2 times 6 times 10 times cos 87, just need to double bracket that, equals, and I get 129.71. So x squared equals 129 point, let me just get that calculator back up, 719.6853. Now, do I need to write all of those down? No, I don't. But one thing I do need to remember is that I've been asked to find x, and this is the value of x squared. So x equals the square root of the answer, which is this. And so x equals, so then on my calculator, I keep that number on the screen. I don't need to keep typing it in, so I just press that and then use the ands function, equals, and it's going to give me 11.4 to 1 decimal place. So it's 11.4 centimeters to 1 decimal place. Now, as always, what you want to do is look at how realistic is that in the triangle. So looking at the other two sides of 6 and 10, 11.4, yep, that seems reasonable, because it needs to be an answer that's between the sum of, or it needs to be lower than the sum of the other two sides. So here, if I add the other two sides, it's 6 plus 10, which is 16, and 11.4 is smaller than that, so that seems like a valid answer for me. So now let's move on to question 2. Let me just get rid of those little things there. So looking at question 2, let's look at this in terms of what we've got. So x here is an angle, so I'm going to call that capital A, which means the 12 is going to be lowercase a, and I'm going to label the other two sides as b and c. So a equals 12, b equals 4.5, c equals 8, and capital A equals x. So here I've got three sides and one angle. So therefore it's going to be the cosine rule, and x is an angle, so the variation of the cosine rule I'm going to be using is cos A equals, and it's b squared plus c squared minus a squared all over 2bc. So substituting those numbers in, I get cos x equals, and it's going to be 4.5 squared plus 8 squared minus 12 squared, all divided by 2 times b, which is 4.5 times 8. And then typing that all in into my calculator, I get, let's just open it up, so I get 4.5 squared plus 8 squared minus 12 squared, roll down, 2 times 4.5 times 8 equals, and it gives me minus 239 over 288. Now you might be thinking to yourself, how can I end up with a negative answer? Do not worry, because again, this is what cos x equals, and I need to work out what x is. So therefore x equals the inverse cos of minus 239 over 288. And if I get my calculator back and do shift, inverse cos of the answer equals, and it gives me 146.1. And that's to 1 decimal place. Now, does that look correct? Well, yes, even though this diagram is not drawn to scale, this does look like an obtuse angle, and this answer gives an obtuse angle. So therefore, it seems realistic that I haven't made a mistake. Moving on to question 3. So again, let's have a look at labeling this. So here again, we've got x is a side, so we'll label that as lowercase a. Almost wrote it as capital A, but there you go. So that's lowercase a. So the opposite angle is going to be capital A, and I'm going to label this as capital B. So this is going to be lowercase b. Now again, I'm not going to label that as C and that as C, because they're both blank sides, so try and avoid it. So then from this, what we've then got is little a is x, capital A is 42 degrees, B is 8, and capital B is 57 degrees. So looking at this, I've got 2 sides and 2 angles. So therefore, I'm going to use the sine rule. Now for the sine rule, I've got a over sine A equals b over sine b. Now again, you could flip those fractions, so sine A and sine b are the numerator, but it doesn't make a difference as long as on both of the fractions the numerator is representing the same thing. So either sides, both sides, or both angles, it's all good. But I'm going to go for this because it's always the one I always use. So substituting numbers in, I get x over sine 42 equals, and then it's 8 over sine 57. So then from this, what you then want to do is cross multiply. So I'm going to multiply this with this and this with this. So cross multiply. And so what we end up is x sine 57 equals 8 times sine 42. So from this, I want to get x the subject. So what's the opposite of multiplying by sine 57 is to divide by sine 57. So x equals 8 sine 42 divided by sine 57. And if I type that all into my calculator, let's get that back on the screen. Get the fraction. So 8 sine 42, close bracket, and sine 57, and it equals 6.38, so 6.4, and it's going to be centimeters to 1 decimal place. Does that seem correct? Well, yeah, I would say so. Moving on to question 4. So again, let's look at labeling this triangle. So x here is an angle, so I'm going to label that as capital A, which means the 7 is going to be lowercase a. This will be capital B, and this will be lowercase b. So then labeling this, I've got 7, A is x, B is 12, and capital B is 96. So again, 2 sides, 2 angles equals the sine rule. So writing the formula out, substituting numbers in, so I've got 7 over sine x equals 12 over sine 96. And from this then, what I then need to do is cross multiply. So I get 12 sine x equals 7 sine 96. I then want to make x a subject, so I take the 12 over to the other side. I end up with sine x equals 7 sine 96 over 12. But then I want to get rid of the sine, so I need to do x equals inverse sine of that entire fraction. So again, reaching for the calculator, resetting it. I've got inverse sine, open my fraction, so I've got 7 sine 96, close bracket, over 12, close bracket, equals 35.5. And that's degrees, and that's to 1 decimal place. Now moving on to an ambiguous case. So looking at this particular question, let's just go through the notions of what we actually need to do. So again, x is an angle, so I'm going to label that as capital A, which means that this is going to be lowercase a. Another angle is going to be b, so that's going to be lowercase b. So from this, I've got a equals 5.4, capital A equals x, b equals 3, and capital B equals 32. So this, therefore, is going to be a sine rule question. So then again, writing the formula and then substituting numbers in, so I get 5.4 over sine A equals 3 over sine 32. So then 3 sine A equals, or x I should say, that's that, and back. And that's going to be 5.4 sine 32. So then sine x equals 5.4 sine 32 all over 3. So x equals the inverse sine of 5.4 sine 32 over 3. And then if I type that into my calculator, so shift inverse sine fraction 5.4 and sine 32 close bracket over 3 or across close bracket equals, and it gives me 72.5. Now one thing that you should be able to spot is that this angle here is obtuse, yet this angle here to 1 decimal place is acute. And that there lies a problem. Now again, even though the diagrams are going to be shown as not being drawn accurately, angles should be the same in terms of acute angle should be acute, obtuse angle should be obtuse, reflex angle should be reflex. So here we have a slight problem. Now what I could do now, from the information that's given to me on the original question, all I know about this triangle is that it's got a side of 5.4 centimeters and 3 centimeters and an angle of 32 degrees. Now with this, if I took this 3 centimeter side and I just moved it along this line here, let's just say that line there was extended, because this side here is the side that I don't know the length of. All I know is that this side here is 3 centimeters, but if I extend that 3 centimeter line, it also still joins with that green line. Now what that has then told me is that this angle here is actually 72.5 degrees. Now, as you can see, that blue triangle that I've drawn is an isosceles triangle. So this angle here is also going to be 72.5, but its angle X is what I actually need to do. So here the actual angle for X, or the obtuse version, is going to be 180 minus 72.5. And again, if I just quickly type that into my calculator, so 180 minus 72.5, it gives me an answer of 107.5, which seems like a more realistic answer for this X, which is an obtuse angle. And that is what we call an ambiguous case. So always look at your answer and check the validity of whether that seems reasonable. And again, with these, they will never be instructed to say this. It's something where you just have to use your common sense and your math knowledge to figure it out.